Good afternoon, everyone. In today's session, we'll be discussing about one important concept called as deductive learning. And with respect to that, we need to first understand what is inductive learning, because both these concepts are vice versa. Like if you are learning inductive learning, it automatically directs you to learn about deductive learning. So these two concepts are reciprocating each other. We have already discussed about what is inductive machine learning, but let's once recall about this concept of inductive machine learning, and next we'll move forward to your deductive learning. Okay, in inductive learning, we are given an input value, input sample x, and an output sample f of x, and the problem is to estimate the value of f, right? So you need to identify the function f. That is the actual problem with respect to your inductive machine learning. This problem is to generalize from the samples and the mapping to be useful to estimate the output for new samples in the future. At the point why we are learning about this inductive machine learning, when we are having other machine learning algorithms, so we talked about this point, like whenever you are having your input samples and you are having your output samples, but you need to estimate some new samples which cannot be done by the prior algorithms. That's the reason inductive machine learning concept is emerged. So it will talk about creating of new samples whenever it is necessary based on the rules whatever specified. So in practice, it is almost always too hard to estimate the function. So we are looking for a good approximations of the function. So inductive learning is one important concept which we need to understand with respect to creation of new samples, that is to estimate the function of f value in the f of x. Okay, inductive learning also, its terminology is like inductive reasoning is a form of reasoning to arrive at a conclusion using limited set of facts by the process of generalization. So while explaining about inductive learning in the previously, we called it as generalization of rules. Let me once go back to that slide and make you clear about that concept, what we have learned about, yeah, inductive learning. So it is here we will be using the concept is in which AI systems to try to use a generalized rule to carry out observations. So this is where we have understood previously about inductive learning. There are types of inductive learning algorithms also, which we have seen previously. Yeah, so that is knowledge based deductive learning, and also here we have seen what is deductive learning and what are the different types of deductive based learning. These are explanation based and relevance based. Okay, so this is also I have said in inductive learning we use if and then rules, and accordingly we will be using some set of rules to predict some new outcomes. Okay, so that's the reason we are not trying to stress more on this inductive learning here. Yeah. Okay. Yeah. So inductive reasoning is a type of propositional logic, which is also known as cause-effect reasoning or bottom-up reasoning. So here the name is indicating bottom-up, which means you need to come from bottom to top for your decision making. Okay. So in inductive learning or inductive reasoning, we use historical data or various premises to generate a generic rule for which premises support the conclusion. The premises, whatever you are going to take, they should support your conclusion. Yeah. So in inductive reasoning, premises provided probable support to the conclusion. So the truth of premises does not guarantee the truth of conclusion. So this is very, very important observation which everybody need to understand here. The truth of premises does not guarantee the truth of conclusion. So the same concept we will be discussing with respect to your deductive reasoning, and there the truth of premises will guarantee to the truth of the conclusion. That is a small difference which we'll be seeing in the upcoming slides. Okay, so here's a small example for you all to understand about what is this inductive learning. For example, I'll take a small premise like all of the pigeons we have seen in the zoo are white. So here's a small premise which is saying that the pigeons present in the zoo are white. Depending on that, there is a small conclusion given here. So therefore, we can expect all the pigeons to be white. So because all the pigeons in the zoo are white, so there is a conclusion that all the pigeon colors are white. That is the conclusion which we can draw using your inductive learning. So the general process of inductive reasoning is given below. So this everybody need to note down and keep in your mind what is the structure or the representation of your inductive learning. So initially we will be having some observations. So based on that, you will draw some patterns, and with that you will come to some conclusion or a hypothesis. From there we will be drawing some theoretical explanation about the concept. Okay, so here this is the structure for your inductive learning. Yeah. So now let's see what are the examples of this inductive based learning or induction. So if I say one example is credit card risk assessment. Here X is the properties of the customer. That is, a customer maybe employed one, or he is a student, or he is a doing some business. What is his previous transactions? All these are the properties of that X person. F of X is the credit card approval pending, or whether it is given or not. That is called, we call as F of X. So here if it indicates whether it should, whether based on the properties we need to give a credit card to that person or not. In the same manner, coming to disease diagnosis, X is the properties of the patient. So whether he is having a lung cancer disease, or whether he is having any other disease, or brain tumor disease, or corona, whatever it is, the F of X is the disease they suffer from. So based on that, a disease diagnosis will say, a diagnosis system will suggest him what medicine he need to take, or what precautions he need to take to overcome this disease problem. And next one is face recognition. Is one area we'll be using this induction concept, where X are the bitmaps of people's faces. So you'll be having some bitmap images like various emotions, various movements, or various styles. F of X is the is to assign a name to that face. So depending on all those features, a particular name will be assigned to that face. That's how it can be used in facial recognition also. And next one is automatic steering, that is driverless car. The X are the bitmap images from a certain, from a camera in front of the car. F of X is the degree that a steering wheel should be turned. So according to the input images obtained in front of the camera, so according to that, a steering should be design, how much degree it should be turning. If there is obstacle in front of a car, what should it do? That is the random thing which will be happening using your inductive based learning. So these are some of the applications for this inductive based learning. Okay, so next we'll talk about the next approach, that is deductive machine learning. So deductive machine learning can be explained simply like it is a teacher centric learning, and we could talk about inductive learning as a student centric learning. So a deductive approach to teaching language start by giving learners some rules, then examples, then practice. So basically whatever the scenario which is happening regularly in our life, like teaching, a teacher will be trying to generate some rules, he will try to provide some examples, then you will be doing some practice. That's how a deductive machine learning approach will move on. So it is a teacher centered approach to presenting new content. This is compared with an inductive approach, which start with examples and ask learners to find rules. So inductive approach, we will be only having examples, and with that examples, we need to find the rules. But in deductive learning, you will be having the rules earlier. Depending on that, you will be having example. Then according to the practice, you will be getting some output. Okay, so hence it is more learner centered. So using your inductive learning, you will be having a lot of learning, because rules should be automatically framed by the user or a intelligent machine here. Okay, yeah. So deductive reasoning or deductive learning is deducing new information from logically related known information. So you'll be already having some information. From that information, you need to grab some new information and provide that for a proper reasoning. It is a form of valid reasoning, which means that the argument's conclusion must be true when the premises are true. So as I said in the previous slide, so inductive learning, there will be no guarantee that if a statement or a premise is true, conclusion will be true. But coming to your deductive learning, so if a statement or a premise are true, the conclusion should always be true. That is why deductive learning is, it is because it's a teacher centered learning. Definitely the answers will be termed as true, because it already has set of rules and examples. And inductive learning, because there are no set of proper rules, it should automatically identify, that may lead to some ambiguity. And as I said, inductive learning is a bottom up approach, deductive learning is a top down reasoning. Okay, so and it is a contradictory to inductive reasoning. Yeah, so this point should be noted here. in deductive reasoning, the truth of premises guarantees the truth of the conclusion. That is very, very important here. Okay, so we'll take a small example and understand this concept. Yeah, so we are having two premises here. From the two premises, we are getting some conclusion. So premise one is stating that all the human eats veggies, and premise two saying that Suresh is human. So because in the first premise we are saying that every human being will eat vegetables or veggies. So conclusion is Suresh eats veggies, right? So that is how we draw conclusions by a set of previously given premises and their explanations. So the process of deductive reasoning is given below. So you can see, compared to this inductive learning, this is the reverse for this inductive learning. So here we will be having theory first, next some conclusions or examples, next you will be identifying the patterns and giving some confirmation. But in coming to inductive learning, there you will be having confirmations, patterns, hypothesis, and then theory. So these two are vice versa. We call it as the reciprocal of each other. Okay. Yeah. So this is one important understanding about what is deductive reasoning and inductive reasoning comparatively. How they two are equal and how they two are separated. Yeah. So talking about differences with respect to definition, deductive reasoning is a form of valid reasoning to deduce new information or conclusion known from related facts and information. And coming to inductive reasoning, it arrives at a conclusion by process of generalization rules. So keep this in your mind whenever you're talking about inductive reasoning or inductive learning. It is generalization using specific facts or data. Okay, yeah. So, as I previously said, this is deductive learning is a top-down approach, and inductive learning is a bottom-up approach. Yeah. So basically, deductive learning starts from premises, and inductive learning starts from the conclusion. So both are reciprocating are each other. So it starts from premises and comes to conclusion. And inductive learning starts from conclusion and comes to the theory at the end. So in inductive reasoning, conclusion must be true if the premises are true. That is the statement validity. So in inductive learning, that cannot be guaranteed. The conclusion cannot be guaranteed if the premises are true. That cannot be 100% true. There may be some ambiguity here. Okay, yeah. So deductive reasoning is difficult as we need facts which must be true. So definitely there should be a proper fact should be given. Then only statements need to be true. But inductive learning is very easy and fast compared to deductive learning, because the conclusion need not to be 100% true, which happens regularly in our life. So in real world, in our daily life, right? So the process, as I said previously, the pattern or the way of indicating this process of deductive learning from theory to confirmation. And here in inductive reasoning, that is observations to theory. Okay, so yeah. So in deductive reasoning, arguments may be valid or may not be valid. In inductive reasoning, arguments may be weak or strong. So that is the difference between these two reasonings or these two learnings about inductive and deductive learning. Okay. Yeah. So the next concept is about clustering in machine learning, which is very, very important concept with respect to machine learning. So previous concepts we have learned about what is a classification, and we have learned about decision tree and support vector machines as part of classification. So now in today's session we'll be trying to learn about next important concept in machine learning is about clustering. So talking about machine learning paradigms, I have said supervised learning, unsupervised learning are two types of machine learning concepts, and also reinforcement learning. So in supervised learning, we have spoke about classification. So now clustering comes under unsupervised machine learning method. Okay, so talking about clustering or cluster analysis is a machine learning technique which groups the unlabeled data set. So because it is a unsupervised learning, the data whatever you are having is not a labeled data. You will be having an unlabeled data, and that unlabeled data need to be understood by a system, and accordingly it need to group the similar things. Okay, so coming to the definition for this clustering. So a way of grouping the points into different clusters consisting of similar data points. The objects with the possible similarities remain in a group that has less or no similarities with another group. So simply I can say that grouping of similar objects into one place is called as clustering. Okay, so depending on the size of data, there can be more than two clusters or three clusters or four clusters. It all depends on the data or whatever you are going to have. Yeah, it how does a cluster form its clusters, right? How does an algorithm, clustering algorithm, identify clusters? So there are n number of features which we can identify. Suppose if I'm taking an example data set which is an unlabeled data set, so it can have attributes such as shape, size, color, behavior, a type of attack, or depending on different parameters available in the data set, it can try to group. Suppose if I say I need to group all the people who are thin into one side, I need to group all the people who are having fat into a different cluster, I actually need to group people who are having white into different color. So that's how, depending on the size, shape, color, behavior, so depending on the attendance marks, so depending on the type of data whatever you are going to provide, you can form clusters accordingly. Okay, yeah. So as I said, it is an unsupervised learning method, hence no supervision is provided to algorithm, and it deals with unlabeled data set. That is the brief introduction to your clustering. Yeah. So now you may be confused about what is clustering and classification, because both are trying to group things, or in classification we'll try to create data into two labels, yes or no. But here clustering is completely different. So depending on the type of attributes you are having and type of data you are having, so you will be trying to create clusters, and accordingly you will try to make some decision. So clustering, in clustering we work with unlabeled data set, and in classification we work with labeled data set. So both are not same, but both can work together whenever data is categorized. So once data is categorized into clusters, so you can go for classification also. Okay, so this is one important concept which everybody will ask about, what's the difference between clustering and classification. So you need to be very clear. Classification is a supervised machine learning concept. Clustering is a unsupervised machine learning concept. So classification it works on labeled data, and clustering works on unlabeled data set. Okay. So these 2 points you need to keep in your mind when you're talking about your machine learning concepts. Yeah. So talking about the uses of clustering, or how, where can we apply this clustering concept? So it can be applied wherever you're having unlabeled data set. So one example or some techniques which we can take into consideration are market segmentation, like for association mining, for market basket analysis you can use market segmentation. There you can apply association mining, which are rule based systems. Then for statistical data analysis you can use clustering. So whenever you're having data which is unlabeled, and if you want to analyze that data, then you can use clustering method. You can use clustering for social network analysis, for image segmentation, for anomaly or intrusion detection. So in this manner, there are a number of applications where are areas where you can use your clustering concept. So talking about social media, Amazon will be using clustering method to for the recommendation system. Okay. Also, Netflix uses clustering method for recommending the movies according to the way interest of a user. So initially, it will try to take the interest of the people, and accordingly, it will try to recommend some movies based on the user interest. So Netflix, Amazon, Facebook, YouTube, all these concepts, all these platforms are using clustering for recommendation of particular product or particular music or videos, whatever it is, right? So that's how we are having a lot of applications with respect to this clustering concept. So here is a small representation of the overview of a clustering method. So initially you will be having a raw data with all these parameters. That is, data will be linked up. So here you can see three different types of fruits: apples, strawberries, and you can see another like guava is available here. So you will be having three different fruits mixed up into single place. That is, a raw data is available. Now you need to apply the clustering method. So here you can see there is a various conditions you are going to keep. You'll be saying if then rules. You'll be forming your own algorithm, and that algorithm need to separate these metrics depending on the conditions what we are going to specify in the algorithm. So depending on the type of data you are having, there are different clustering algorithms which we'll be discussing in next slide. Okay, yeah. So as I said, different types of clustering methods. Clustering methods are broadly divided into two types. One is hard clustering, other one is soft clustering. So hard clustering indicates data points belongs to only one group. Soft clustering means data points which can belong to another group also. So based on these two categories, clustering methods are classified into five types here. One is partitioning clustering, which is the basic clustering method. Next one is density based clustering. So these are the different clustering methods, only types of clustering methods. So for every clustering method, we are having different clustering algorithms again. Okay, so if you are because we are talking about clustering for the first time in our complete career, we are going to talk about the broad clustering concepts. That is, what is clustering, like what are the applications of clustering, and what are the types of clustering. So in-depth concept of these all concepts of partition clustering and all these concepts will be discussed in the next semester about your machine learning concept. Okay, so however, we'll be trying to cover all these concepts in today's session. I'll be giving an overview of what are these methods and how they when and where for which type of data we need to use these clustering methods. Okay, so everybody need to keep these names in your mind. So first one is partitioning clustering, next density based clustering. So depending on the type of data you are having and what is the dense of your data, you'll be having density based clustering. Next, you'll be having distribution model based clustering, and next hierarchical clustering and fuzzy clustering. Okay, so these are the different types of clustering methods available in your clustering algorithms. Okay, so here is an overview of all the different algorithms, methods of clustering. So first one is partitioning method. As I said, we'll be talking about overview of this, and next we will be talking about each and every algorithm specifically. So these methods partition the objects into k clusters. So k can be 3, 4, 5. So depending on the type of data you are having, you need to design the value of k, and each partition forms one cluster. This method is used to optimize an objective criterion similarity function, such as when the distance is a major parameter. So if you want to use apply partition methods or partition clustering, you need to compute the distance between the objects. That's why you will be using Euclidean distance, Manhattan distance. The various distance metrics can be used in this concept to find the nearest clusters. So k-means algorithm is the example for these partitioning methods. So everybody need to remember these examples, algorithms, because in the upcoming years, upcoming sessions, you will be learning about this concept of clustering. So k-means is one important clustering which comes under partitioning methods. Next one is Clarence, which is clustering large applications based upon randomized search. That is abbreviation for this Clarence. So these two are the most widely used clustering methods. There are still very different methods available for partitioning methods. Next method is density based methods. So here these methods consider the clusters as the dense region having some similarity. So depending on the size of the data provided and depending on the denseness of the data, it will be trying to calculate the density. And these methods have good accuracy and ability to merge two clusters. So it can easily merge two clusters and make some decisions. So the example for this algorithm, this method is DB-scan, that is density based cluster, density based spatial clustering of applications with noise. So whenever you are having your data which is very dense, the example is spatial data, then you can apply this density based DB scan approach. Next one is optics, that is ordering points to identify clustering structure. These are the example algorithms which are used in density based methods. In upcoming years, you'll be learning about all these classification, all these clustering algorithms. Okay, and next method is hierarchical based methods, that is representation using a tree based structures. So new clusters can be formed using previously formed one using the hierarchy of the data. So here we are having again two types of approaches. One is agglomerative, other one is divisive clustering approach. So agglomerative comes under bottom up approach and divisive is top down approach. So examples for these methods are Cure, which means clustering using representatives. Next one is BITS, using blazed balanced iterative reducing clustering and using hierarchies. So this is how you are going to learn about various clustering algorithms which are linked up to various methods. And next one is grid based methods. So this is useful for high dimensional data. So in this method, data is space is formatted into a finite number of cells that forms a grid like structure. So depending on the type of structure, these algorithms have been designed. So I'll be explaining about each and every algorithm in the next slides. Yeah. So the examples for this approach are STING, that is statistical information grid, and wave cluster, click, that is clustering in queues. So yeah, these names are very important, which everybody of us need to remember. Okay, the abbreviations, the names, that should be remembered by everyone. Yeah. So now talking about each and every clustering in depth. So initially we were talking about partitioning clustering. So as I said, k-means clustering is the example for this concept. So you need to separate data points with respect to some distance and centroid calculations. So initially you will be calculating some distance metrics, and later you will be identifying a centroid value, and from that you will be separating your clusters into different regions. Here you can see green is one area which is representing the triangles, red indicating the circles, and here you can see the hash color indicating the squares, and next again you can see the broader circles here. Okay, that's how using the centroid you are going to separate your clusters. So here you are having 4 clusters. Each cluster is having its own unique identification, and here you can see in triangles there are no circles mixed up. That's how you need to separate your uh, clusters and data points in the clusters. So here this is one cluster, this is second cluster, third cluster, and fourth cluster, and in the cluster you are having some data points that will be given in the data set. Okay, yeah. The next clustering algorithm you can see, which is based on the density based clustering. As I said, DB-scan approach is the example for this density-based clustering. So depending on the denseness of the data points, the clustering algorithm works accordingly. This algorithm does it by identifying different clusters in the data set and connects the areas of high densities into clusters. So whichever the data points are highly connected, they are formed into one clusters. So the dense areas in the data space are divided from each other by sparser areas. Okay, so here you can see the points are very nearly or densely available, and here you can see the points are serially available, and here you can see the points are densely available. So that's how we'll be trying to identify each and every cluster space, and we can also form internal clusters according to the size of the cluster. Suppose assume that here you are having a density based cluster which is of bigger size, and if you want to still partition or divide into smaller clusters, that can be done according to the data samples whatever you are having. Okay, so these algorithms can face difficulty in clustering the data points if the data set has varying densities and high dimensions. So here, because we are having only 2 types of data points, it is not difficult to categorize. But if you are having different samples of various densities, then it is very difficult to identify this type of clustering. Okay, yeah. Next one is a distribution model based clustering. So this is basically about your Gaussian distribution. So here the data is divided based on the probability of how a data set belongs to a particular distribution. Expectation maximization concept, which is a clustering algorithm, is used in this example. So here you can see depending on the radius of the size of the clusters or data points, clusters are formed based on the various radiuses. Okay, so here you can see 1 2 3 clusters are formed internally for this red sample. Again, here you can see depending on the sizes of the clustering, if you are having thickness, they are grouped into smaller clusters. If depending on the radius or the separation of the points, you are having the higher clusters. Okay, that's how based on the distribution of the points, clustering can be done. Next one is hierarchical clustering, which can be used as an alternative for the partitioning clustering, and there is no requirement of pre-specifying the number of clusters to be created. So initially, depending on the data points obtained, it will by default take the data points. So in this technique, the data set is divided into clusters to create a tree-like structure, which is called as a dendrograms. So here you can see these are the dendrograms which are represented using your hierarchical clustering. So it is similar to a tree starting from one point to parent to the child nodes. It is being divided. The observations or any number of clusters can be selected by cutting the tree at the correct level. Suppose if you want to form a cluster at this point, you can cut this point and form a one cluster. So according to the specifications of the data points, you can construct your own clusters. The most common example is agglomerative. As I said, you will be having agglomerative and divisive clustering. One is bottom to approach, bottom top, and one is top to bottom approach. Okay. And the next method is fuzzy clustering, which is not discussed earlier. This is a separate clustering concept. So fuzzy clustering is a type of soft method in which a data object may belong to more than one group. So as I said initially, clustering is divided into two types. One is hard clustering and soft clustering. So if data points are grouped at the same clusters, it is called as hard clustering. And if the points are available in another cluster, it is called as soft clustering. So fuzzy clustering is an example of soft clustering. So here the data objects may belong to more than one group of or more than one clustering. So each data set has a set of membership coefficients which depend on the degree of membership to the in the cluster. So fuzzy K means or fuzzy C means is the example of this type of clustering method. Okay, yeah. So talking about applications of clustering, clustering has wide applications, as I said, in different areas like market segmentation, anomaly detection. There are different approaches. So talking about each and every application one by one. So initially to identify the cancer cells in the body, so because they are very densely available in the body, so the clustering algorithms are widely used for the identification of cancerous cells. So it divides the cancerous and non-cancerous data sets into different groups. So whichever the cells are which are grouped to the cancerous part will be formed into one cluster, and whichever the points which are not having any symptoms of cancer, they will be grouped into the other cluster. Okay, yeah. And next one, the next application of clustering is in search engines. So in search engines, when you are typing a query, whichever the concepts or the methods similar to your query, they will be grouped into one area, and whichever the topic is not relevant to your query, then that will be not be recommended. The search result appears based on the closest object to the search query. Suppose if you are selecting cricket as example, and if you are typing ICC cricket or test cricket, all the test matches will be coming according to the query whatever you are going to ask, right? So it does it grouping by similar data objects in a one group that is far from the other dissimilar objects. So because your search query is based on the cricket, so you will be getting only recommendations or the results based on the query of cricket. You will not have any query related to your football or any other hockey or any other game, right? So that's how search engine uses clustering method. Next one is customer segmentation. As I said, in market research for market-based analysis for recommendation of products, you will be using your, and also for online recommendations from Amazon for product recommendation, it will be using customer segmentation. For that, we will be using your clustering algorithm. And in biology, also we'll be using clustering. In chemistry, we use clustering. In biology, also we use clustering to identify the species of plants and animals using the image recognition technique. So related to land or spatial recognition, you can use clustering for different approaches. Okay, yeah, that's it about your clustering concept, guys.